All right. Well, Dr. Dayspring, thanks for joining us. It's been a couple of years since we last spoke, and it's really nice to see you, via Zoom. I think last time we spoke it was over the phone, so good to see
Yep,
you.
I'm back.
And good to have you. And so when we kind of chatted briefly to set up this call, we were talking about a lot of different things that I want to get into today. But I think where we left off was pretty interesting to me because I know when I've heard you interviewed by Peter Attia and some others, you've talked about how a low carb diet was successful intervention for you, but you're also concerned about the impact of a ketogenic diet on a lot of people's lipid profile. So could you kind of tell us how you walk the fence on that line?
Yeah, several years ago when Peter got me started, we went on a program of low carb, not ketogenic diet, and mixed with intermittent fasting. And at that time, that was 5 days straight once a month, where I would eat probably less than, ultimately it's supposed to be 700, but I was eating less than 400 calories on those 5 days. And one or two of the days, as I got really used to starvation, I would sometimes eat nothing. So that mixed with a hypocaloric, low carb diet, the 3 weeks that I wasn't doing the fasting, really worked well. I ultimately shed 70 pounds. I improved a little bit of borderline insulin levels. I had my fatty liver, the transaminases rapidly improve. So it was good for me. Uh, if I had to do it all again, I probably wouldn't want to do the 5 days. I did it 4 years, like biblical. I stayed on the regimen. And then COVID came along and, got a little less fastidious in what I'm doing and everything. So I gained some of those pounds back, nowhere near what I was. But I wouldn't do the 5 days intermittent fasting. You have to be really motivated, which I was at the time. And I don't know that I have that motivation anymore. But I think anybody was an insulin resistant overweight guy, like so many people in the world. Uh, I think if you just did restrict your carbs a little bit and you definitely reduced your calories, you're going to lose weight. I was exercising a bit through all of that too on a treadmill, mostly aerobic exercise. So that didn't hurt. And I was doing that every day too. But I didn't go ketogenic. I would never go ketogenic. I think that's a tough diet to stay on religiously. And I'm talking about where you're checking your ketones all the time and you know you are ketogenic. A lot of people think they're on ketogenic diets and they're nowhere near what should be for that. And as you know, if you're going to do ketogenic, you better watch some of your lipid metrics because X number of people who do that blow their lipid parameters out of the into the sky, and they either have to adjust that diet with different types of fats, go on therapy, or forget the ketogenic diet. You'll lose your weight elsewise.
Yeah, but I mean that's sort of like the issue that's at the forefront of all these conversations. Like I have a good friend who just went on and there's millions of examples like this, but I have a good friend who just went on a ketogenic diet, lost a ton of weight, but they fall under the care of physicians who tell them, don't worry about LDL-C, don't worry about ApoB, don't worry about cholesterol. That's all, been debunked. That's all garbage. And it's discouraging, right? I mean, it's discouraging to see people out there who are pursuing a nutritional intervention with the idea that ApoB is not something that they
Yeah,
need.
look, they're getting uninformed advice. The legitimate lipidology world, the nutritional world, who isn't often at la la land, reject that. The data is overwhelming that if you elevate LDL cholesterol, non-HDL cholesterol, apolipoprotein B, LDL particle count, your risk goes higher and higher and higher. It's not even debated. Tons of observational trials, tons of clinical randomized blinded trials, and all sorts of Mendelian genetic, probably the best type of evidence shows ApoB is causal. And a little bit on that. It's not ApoB that causes atherosclerosis, but ApoB does not exist as a single protein in plasma. ApoB is always enwrapped with lipids, mostly cholesterol, some triglycerides. So if the ApoB particle carrying cholesterol exceeds the concentration threshold, it enters the artery wall. and it gets eaten by a macrophage, but it's the cholesterol that causes the atherosclerosis. But cholesterol would never get into the artery wall if it wasn't carried in an ApoB particle. So they want to believe what they want to believe. Personally, you are playing Russian roulette. That's what you're doing. Might there be the oddball exception who somehow screws up their lipids and particle concentrations who doesn't suffer consequences? There's always flukes like that in medicine, but the overwhelming majority are putting their lives and their vasculature at risk. And they go and they get their coronary calcium and it's 0. Great news. So that means you've got a little bit of time to play before atherosclerosis comes in, but stay on the ketogenic diet, put your ApoB through the stratosphere, and repeat that coronary calcium in 10 years. They don't. Few people ever stay on a ketogenic diet 10 years, so maybe it's not a worry. But to think you can dismiss ApoB or cholesterol metric science, look, it's a free country. Do what you want. It's Russian roulette.
It seems to me like what's happening is you have people who have developed these instant reactivities to different foods in the form of food sensitivities. So they strip out foods that they're reactive to in the short term. And it's kind of like a mortgaging of their long-term health because they're ignoring these lipid markers. But before we get into cholesterol, because I want to talk about sterile panels and statins and all that good stuff, all-cause mortality. Before we get there, just to close this issue. So you said you're going low carb. I think there's a lot of people at home who are just totally dumbfounded by this. It's like, okay, you're worried about the lipid impact of a ketogenic diet, but you're on a low carb diet, because the people that are advocating by and large for a low carb diet are people who are sort of pushing the lipid markers to the side. What does a low carb diet look like for you that also keeps your lipids in check?
Well, I think for most people, it's probably less than 50 grams of carbohydrates a day would be your, most people are obese, are eating 200, 300, 400 grams of carbs a day because that's all they eat. So if you brought it down to that level, you're not going to go ketogenic until you start getting it well under 20 grams per day. And like I said, that's a very unpalatable diet unless you want to suck on butter all day long. So few people could do it. But I don't know if pick every diet that's probably ever somebody's thought up. You lose weight most of the time because you're restricting calories. But the study after study shows a year later, almost nobody keeps that weight loss off. So that's another problem in nutrition and everything too. So ketogenic diet, you want to play with it for a few months, be my guest, blow your ApoB. A high ApoB, the good news, it takes decades to develop atherosclerosis. You could send your ApoB through the stratosphere and you're not going to get visible and atherosclerosis you can at least detect through any imaging procedure. You'd have to be biopsying your artery to see fatty streaks developing. So short term, it doesn't matter what the hell you do. So if you love the ketogenic diet for a year or two and it helps you lose weight and you're happy with that, good. And hopefully, there is 0 long-term data on that type of diet, and there is much better endpoint results on a lot of other diets that are out there. So,
fair enough. Okay, I hear you there. I mean, let's get into a topic that I, as a sort of like a aspiring lipid nerd, find very interesting, which is I want to start by asking you this: do you think it is? I hate to use the word unethical because I think that's hyperbolic, but do you think that it is problematic for a cardiologist to prescribe statins without first running a sterile panel?
No, because most doctors don't have access to sterile panels. They wouldn't know how to interpret them if they got the report back. So I think an initial first step for most people is going to be base your therapy. They do it on cholesterol concentrations in a standard lipid panel, LDL-C, or better yet, they should be using non-HDL cholesterol. Those in the know are doing ApoB or LDL particle counts through other methodologies in using that. Now, that being said, so you got a high ApoB, you got to get on something. Statin is pretty much going to be part of any therapy you're going to use. There are people that maybe a cholesterol absorption blocker would be a better first-line drug if you want to go stepwise. But So I wouldn't say it's malpractice or unethical, but if you did get the sterile panel and you would then ascertain whether this patient is a hypersynthesizer of cholesterol or a hyperabsorber, that's valuable knowledge. At the end of the day, the only way we can reduce ApoB, LDL particle count, is to have the liver upregulate LDL receptors, which are expressed on the surface of the hepatocyte where it interacts with the plasma. And those LDL receptors grab ApoB, that is on the particles that are floating by. Once the receptor grabs the ApoB particle, it internalizes it into the liver, where the particle is catabolized, and then the liver does what it does with the cholesterol and other lipids that are induced. So how do clinicians induce the liver to express more LDL receptors? There's three ways right now. One, well, the first step is you have to deplete the hepatic pool of cholesterol in the liver. The liver always has a certain amount of cholesterol in the cytoplasm of every hepatocyte. That's called a pool. Now, if the liver needs cholesterol, genes will express proteins that gather cholesterol. If the liver doesn't need cholesterol, the genes will induce things that get rid of cholesterol. The liver gets rid of cholesterol via putting it in the bile directly, changing cholesterol to a bile acid, which goes in the bile, goes down to your gut, and it can be excreted. The liver can efflux cholesterol out of the liver cell into a cholesterol acceptor protein called apoprotein A1. If ApoA1 gathers cholesterol being pumped out of the liver, it evolves into an HDL particle. So a lot of the liver's cholesterol is given to HDLs. Now, what do HDLs do with that cholesterol? They are the deliveries of cholesterol to your steroidogenic tissue, adrenal cortex and gonads, ovaries, women, testicles, men. That is how those organs get cholesterol, apart from what they synthesize de novo. The liver uses cholesterol in its own cell membranes. So now you have that pool of cholesterol in the liver. If I could deplete that pool of cholesterol, the liver's in big trouble because the liver needs cholesterol to make bile salts, to put in its membranes, and to lipidate HDL particles. So if the liver pool of cholesterol is small, there are nuclear transcription factors that sense that, deficiency of cholesterol, and they move into the nucleus and they go over to the DNA, these nuclear transcription factors, and they say, hey, where's the part of the DNA that makes things that will give the liver cholesterol? And one of the biggest regulating proteins that will be expressed if the liver needs cholesterol, the genes will tell the protein-making apparatus called an endoplasmic reticulum to make an LDL receptor. And that LDL receptor, once it's synthesized, it breaks loose and it translocates. That means it moves through the liver cytoplasm to the surface of the liver cell, and there it's expressed and grabs more ApoB particles. So how do I deplete the pool of cholesterol in the liver? Because I, as a therapeutic physician, want the liver to express more LDL receptors. I either stop synthesis of cholesterol because the pool will shrink, the cell will make more LDL receptors, clear more ApoB particles, ApoB, LDL cholesterol, non-HDL cholesterol, LDLP goes down. Or I could block the absorption of cholesterol at the intestine. If I did that, the chylomicrons, which are supposed to gather absorbed cholesterol and bring it to the liver, all of a sudden would be cholesterol deficient. There would be a lesser delivery of absorbed cholesterol to the liver. The liver would say, oh my God, we're not absorbing cholesterol. I'll just make more LDL receptors and I will replenish my cholesterol by clearing ApoB LDL particles. So if ahead of time I knew a patient was a hyperabsorber, I would prescribe Zetia. Ezetimibe is the first-line drug because that's the pathological problem in this person, why they're not clearing their LDL particles. If I noticed the synthesis markers were high, I'd say, oh my goodness, I can express more LDL receptors simply by inhibiting synthesis of cholesterol in the liver. And that's where either a statin or the newer bempedoic acid would come into play as a possible therapeutic. So knowing steroid concentrations the two that reflect absorption, the two that reflect synthesis, you could precision what your first line therapy is. Hypersynthesis, a statin, bempedoic acid, hyperabsorption, ezetimibe. You will see some people where the system is broke. They both hypersynthesize and hyperabsorb. That's almost day one, a low dose statin plus ezetimibe, and you will rapidly improve the lipid parameters. You can go stepwise. And the last thing about that, this is why you shouldn't go stepwise. Because if you just prescribe, say, a statin or more statin and bempedoic acid, because a statin is stronger, and you inhibit cholesterol synthesis, your body says, uh-oh, synthesis is not occurring. The body simply absorbs more cholesterol. So in part, you defeat what the statin is doing by upregulating cholesterol absorption. But au contraire, if you just give ezetimibe monotherapy and you block absorption, forces go into play. It's them damn nuclear transcription factors that tell the nucleus, oh my God, we're not getting a delivery of cholesterol because Zetia is blocking it. Just increase the synthesis enzymes. So when you prescribe Zetia alone, there's a little bit of an increase in synthesis, which in part defeats what Zetia is doing. Now, look, that reflex actions are not that severe that they negate everything a statin does or negates everything Zetia does. But if you were monitoring sterols, you would know that. Oh my God, my Zetia did pretty good. It blew away the absorption markers, but the synthesis markers are up. You add a statin to the ezetimibe if the ApoB is still high. Vice versa, if the statins haven't lowered ApoB to where you want it, but the statins are inhibiting synthesis, but they've screwed up absorption, you would add Zetia to the statin. So this is where these sterile markers can help you in what Peter Attia would call medicine 3.0. Most people call it precision medicine.
Yeah, I mean, when I've heard Peter Attia talk about this just in some of his past podcasts, I know he mentions, just to come back to the importance of the sterile panels and kind of flesh that out more. I mean, he talks about if you put somebody on a statin, and I'm sure this is, something he discusses in tandem with you. I know you're on his team, but if you put somebody on a statin, you have to retest their desmosterol to make sure that you haven't put their synthesis close to zero, because that can be
that's another issue, but right. That's another thing you want to follow up on.
For me, just as a layperson, and for the people that are listening who have who are just looking for a way to distill this down to simple rules, I just am surprised that there's not more of an awareness of the sterile panels, because again, like I've discussed this with you, off the call, is like, look, I can share my own personal story. I think it's helpful for people to hear personal anecdotes, not dispositive, but helpful. So I have, we run a site called Gene Food. So we're doing polygenic risk scoring. So I know that I have, mutations in the ABCG5, ABCG8 pathways. And I've seen both my mother and myself get into range just with Zetia as a monotherapy. Now I guess it makes sense, from a mechanism standpoint, that if you have Zetia, that it could upregulate, synthesis and get your lipids out of whack. But what about somebody?
Just a little bit. It doesn't really, you just know when you use Zetia, if you haven't normalized ApoB with it, one of the reasons might be because you've increased synthesis. And you would see that in the panel. So that's the perfect marriage where I got to add a little bit of statin to Zetia, or vice versa if the statin increased absorption.
Yeah. I mean, when I've eaten super clean and gone on probably what's my optimal diet, I've seen, ApoB in range. I've seen every marker in range. I've seen sitosterol sometimes off the charts. If I'm eating a lot of like sunflower seed butter or something like that, I just feel like it would be a very powerful tool for people to understand that Zetia is out there. Maybe it's 10 to 15% of the population. Now, you mentioned like the rule of cholesterol homeostasis. You eat more cholesterol, your body makes less, you eat less.
No, that's not true, because about 75-80% of the cholesterol you're absorbing is not from ingestion. It's from cholesterol that the liver wanted to get rid of, excreted in the biliary tract into the gut, and it becomes part of the gut pool of cholesterol. So if you examine the gut pool of cholesterol, and that is available for absorption, depending how the receptors are working or not working, 75-80% is biliary endogenous cholesterol, 25% or less is ingested. So that's why, for the most part, eating cholesterol has no effect on your serum cholesterol. The people where it might would be hyperabsorbers of cholesterol, and there are genetic reasons why that might be there. But even then, unless they're on a ketogenic diet, eating 20 eggs a day, most people are not overeating cholesterol that much, that even if you're a hyperabsorber, you're going to screw up your ApoB or your cholesterol metrics. In some, it might be. The one group of people, I as a clinician would say, hey, in your nutrition, you should restrict cholesterol a little bit, would be those that I have shown via the Sterol panel are significant hyperabsorbers of cholesterol. Later on, we can get into, you jumped way ahead to, you started to discuss some of the genes that control the receptors that regulate absorption in the intestine. And those loss of function of those genes are way more prevalent than people recognize.
Yeah, I mean, it's probably, 15 to 20% in some, with some, variation in what would be like the wild type. I mean, for me though, just to finish out this topic, people are very interested in eggs. So two-pronged question. When I'm taking Zetia, and I'll take it, 10 milligrams a day. Sometimes I'll take 5, sometimes I'll take it every other day. I've seen studies that show that, 5 milligrams is just as effective as 10. And I don't know if you have an opinion there. But
I was involved with Zetia when it was, before it came on the market. I was working with Merck as a analyst and consultant to give them, so I know that very well. So in general, the FDA approved 10 milligrams. The FDA sort of looks at what is the maximum dose that will really be effective and you're not going to hurt anybody with it. So it's a pretty benign drug. But Merck had to do serious dosage studies to show what are the other ones. So when you start going less than 10, you don't lose a lot of efficacy. And when it used to be a branded drug and cost money, we often had people just take it every other day to save money. But you can get away a little. It's not, 10 is always the best. You lose a little bit, but not much. And how much you lose depends on the genes you're talking about. If you're a hyperabsorber and you cut the dose, maybe you're playing with far. But if you're not a hyperabsorber, it matters less.
Well, and then the second prong I want to get your take on is, and I think you've probably already touched on it, but the way I look at it is, when you're taking, if you have these genetic predispositions, and then you also have the sterol panels that corroborate, it shows, look, you're really absorbing plant sterol and the cholesterol that you eat at a greater capacity than somebody else. I view it as like a bit of a safety belt for having a low carb diet that's just a safer low carb diet for my individual footprint, because I can rely on some nut butter. I can rely more on eggs. I can rely on lower glycemic, what would be healthy options for some people, might not be as healthy options for me, but are converted into healthy options because I have this backstop of Zetia, which corrects in some way a genetic, problem that I've inherited.
Yeah, it's kind of interesting. The most common, look, we're going to have to just explain how cholesterol absorbed into the intestine. So you have this pool of cholesterol in your small intestine. Most of it is endogenous biliary. Some of it is ingested. Now, there's got to be a receptor there that grabs the cholesterol or other sterols that you might have eaten. And plants are full of phytosterols, very similar to cholesterol, but they're a little different. So that receptor, which is called the Niemann-Pick C1-like one, grabs sterols and it pulls them directly into the enterocyte, the cells that line the intestinal lumen. Now, so they're in. If you happen to have loss of function of Niemann-Pick because you have loss of function of the genes that control the Niemann-Pick, you will be a hypoabsorber of cholesterol. Kind of interesting, in the Mendelian data has been published. Now, if you lose function of that influx receptor, your LDL receptor drops about 10 or 15 milligrams per deciliter. But it's a lifetime of having 10 to 15 milligrams per deciliter less of cholesterol. It's from the day you're born to the day you die. Those people have significantly less heart disease with even that minor a drop in LDL cholesterol.
Okay, I was going to say, because you said LDL receptors. So those people just have lifetime lower baseline LDL cholesterol,
Yes, and you would think, oh boy, to save lives, you'd have to drop your cholesterol 100 milligrams. No, you know the rule: 1 millimole of reduction of cholesterol is like a 3 to 4% reduction in cardiovascular endpoints. So that's a tremendous lifelong That's like they were born on taking ezetimibe, because they're just not absorbing a lot of cholesterol. But let's go now. So the Niemann-Pick has pulled cholesterol into the enterocyte. Now there's a pool of cholesterol in the enterocyte, which technically is going to put them in a chylomicron and have it brought to the liver. Some of it will get effluxed out to an HDL particle, which then brings it to the adrenal gland or the gonads. But if that Niemann-Pick, for whatever reason, absorbed too much cholesterol or sterols that should never be in the human body, phytosterols, there's another receptor that recognizes that the Niemann-Pick overabsorbed these sterols. And it's what we call a heterodimer. It's two receptors that fuse together. They grab excess cholesterol or any phytosterol that got in, and they immediately efflux it back out to the gut lumen so it can be excreted in the stool. They are called the ATP binding cassette transporters, G5 and G8. ABC is the abbreviation. So our intestines have Niemann-Pick C1 like one, NPCL1, and they have ABC G5 and G8. If both of those receptors work in perfect tandem, you will have normal absorption of cholesterol. And Niemann-Pick just brings it in, but the real police are the ABC G5, G8 say, whoa, get the hell out of here. Niemann-Pick let too many people into the club. Niemann-Pick is like the initial bouncer, but ABC G5, G8 is the final bouncer. The problem is everything is controlled by genes. So if you have loss of function of the ABC G5 or G8 gene, either one, you will have a broken intestinal cholesterol efflux pump. If the ABC G5 G8 is not effectively effluxing it out to the lumen, it's going to go in your chylomicrons and your HDL and gain systemic exposure. And this is how the tests we use to monitor absorption are those plant sterols, phytosterols. And why do we look at them in the blood? Because humans cannot synthesize those. So if I see you got phytosterols in the blood, I know, oh my God, you shouldn't have absorbed these. You are a hyperabsorber. Now there a little bit can get in anybody, but once they exceed a certain concentration, if you're overabsorbing phytosterols, you're sure as heck overabsorbing cholesterol. So that's how the two markers, cytosterol and campesterol, the phytosterols, are used. And it's good knowledge to know a person is a hyperabsorber because we can treat that with Azedia if the ApoB is high. If you're a hyperabsorber, but ApoB is normal, we don't worry about it unless you're a massive hyperabsorber. That's called the phytosterolemia. That's pretty rare, 1 in a million. So, and that would be treated with Zetia also. So you have the balance of those influx and efflux receptors controlled by genes.
So, and correct me if I'm wrong, but that's why you have a lot of cardiologists that love oatmeal, right? Because you have these plant sterols that are in oatmeal. The body preferentially and is supposed to temporarily absorb the sterol in the oatmeal, absorbs it to the exclusion of cholesterol, and then eventually kicks it back out. But if you're somebody who, as we're discussing this, phenotype who is has these genetic predispositions and then eats this way, you're getting all of this sterol into the places it shouldn't be, and it's a shame you see people prescribing sterol supplements to lower LDL.
Well, that is actually malpractice if you give a phytosterol supplement like the cytosterol products that are out there to a hyperabsorber of cholesterol, because then you can really send the phytosterol level in the plasma to pathological levels, not the type that you see with homozygous absence of ABC G5 or G8, which gives you massive levels, the phytosterolemia, which causes disease in children, for God's sakes. But still, you shouldn't have excess phytosterols in your blood. They're injurious to so many tissues. So I don't want to see beyond a minimal trace. So yeah, if you give phytosterol supplements, and by the way, a vegan would eat about 700 milligrams of phytosterols a day. These supplements give 2,000 milligrams of phytosterols. So if you've got broken ABC G5 and G8, they get absorbed. They can't be efflux efficiently. They wind up in your lipoproteins in the blood, which means they wind up in your cell membranes where they are injurious. So that's so if you're going to tell a hyperabsorber, take phytosterols, you could be aggravating and causing pathology. The problem is most physicians don't know who's a hyperabsorber or not because they're not doing the sterol testing. And look, I think if you are going to prescribe phytosterol supplements, which would compete with cholesterol for absorption, you are replacing cholesterol absorption with phytosterol absorption. I'd much rather have cholesterol overabsorption than phytosterols. Cholesterol, the human body knows how to handle. The human body does. The only way the human body handles excess phytosterols is eviction through ABCG5G8. But if you have loss of function of that, those phytosterols are free to go invade various tissues in your body and potentially cause harm.
Okay, that just underscores for me just how important Zetia is for some people, right? Last thing on this, what about TMAO? I mean, one of the things that comes up all the time.
Look, I don't even want to discuss this. It's nowhere near ready for prime time. There's no serious data on that.
That's valuable. I mean,
look, people want to measure that. As long as you're doing what you got to do to get ApoB, you want to go chase these other crazy pathways, be my guest, but don't ask me to comment on that. That's in zero guidelines. There's zero level 1, level 2 evidence to support looking at that.
Honestly, I think that's I mean, just that answer to me, I think is fascinating. It's something that's always been in the back of my head because there are those New England Journal of Medicine studies. But I mean, you're on the cutting edge of this, and if you're not concerned about TMAO, I'm a hell of a lot less concerned about TMAO.
Yeah, listen, who knows? In 20 years, are they going to do the type of trials that would prove that's important? I don't know. I'm always open-minded, but they've done no such trials to validate that marker. I can name 20 other biomarkers you could test too that all sound good because there's some study here or here that says, hey, if you lower this, that's probably good. Nobody has, of course, subjected that to large clinical trials to look at cardiovascular outcomes. So that's the problem with that. They all sound very interesting. You read the Stan Hazen papers, they're, wow, this sounds really cool, but okay, prove it to me.
Okay. I mean, that's incredibly interesting and valuable as far as I'm concerned. Now, all right. So I wanted to get into all this sterile. I'm very interested in the whole diagnostic aspect of sterile panels as they jive with genes, just because I've seen it in my own life that I think it's an impactful thing. But almost like the catalyst for this conversation, which I want to close out on, spend the last 15 minutes or so on, is I mentioned you when we spoke. I have two babies under 2 years old at home right now, right, which is just insane. And but I'm thinking to myself, like, okay, once we get them out of diapers, because I've seen you start to beat this drum, right? Like, this is the way to expand longevity, is to get kids tested really early for the types of stuff we're talking about, right? Like their genetics, their lipids. How early would you be doing lipid panels on kids?
Well, I think the pediatric guidelines have this pretty solid. Look, if parents come in and either of the parent is known to have familial hypercholesterolemia, probably after age 2, those kids should be tested for cholesterol, because God forbid a kid winds up with homozygous familial hypercholesterolemia. There have been kids getting heart attacks at 5 and 6 years old. So, but a simple cholesterol test at age 2 would show the cholesterol is way higher than it should be for a kid. Those kids are actually put on statin therapy. Now, look, they're 1 in a million, so you're not going to see a lot. But if it happened in a freak, it was your kid that had hypercholesterolemia, you'd want them treated. Most of the time, by the age of 7 or 8, the kid should be tested. I think between 5 and 8 is good, because at age 5, you can also check Lp(a). It's at the adult level by about age 5. So if you're going to test lipids in a kid age 5 to 8, and you're waiting that long because neither parent is known to have familial hypercholesterolemia or some other rare genetic lipid disorder, you would then look at the cholesterol panel, total cholesterol, LDL cholesterol, and you'd have a once-in-your-lifetime test for now Lp(a). Now, if any of them are out of whack, we now know the guidelines, depending on what levels they're at, you start kids on pharmacologic therapy And you try to install in that kid a type of reasonable dietary measures. And if we start instructing kids at age 7 and 8, right, it's impossible at age 20 to, most people don't want to hear about a diet because they've lived their whole lives with junk food or whatever. So, yeah, that is the standard. And look, even if you somehow missed it in the pediatric age, adolescence is fine to check those things then, unless they have some rare genetic fluke. Teenagers might have elevated cholesterol, but they'd be in their infancy with atherosclerosis development. But the rule for ApoB, when I say ApoB, I'm talking about collectively, that's the best marker of LDL cholesterol, non-HDL cholesterol, LP little a cholesterol, and LDL particle count. So ApoB encompasses all of that. If your ApoB is high, we now know lower is better, longer is better. Mean once you start on an ApoB lowering therapy, you're probably going to be on one ad infinitum. But the new key is earlier is better. It's called primordial prevention. You don't wait till the kids have fatty streak. We have all sorts of pediatric studies in kids who get run over by a train or hit by a car between the ages of 5 and 10. And on autopsy, they show significant fatty streaks in their aortas. That's the initial stage of atherosclerosis. We unfortunately know from all the military studies, if you take young men, 18 to 21 who get killed in battle and they get autopsied, it's shocking the atherosclerosis that is present in so many of those people. Had they started lipid therapy when they were 8, 9, 10 years old, look, the soldiers would still unfortunately be dead because it's trauma. But if you survived military service, or you're a kid who hasn't get hit by a car or run over by a train, you have taken out the global #1 cause of morbidity and mortality, atherosclerosis. It has to be hit in its infancy. So that's what we need to do. And that's why this testing, everybody's on board now. It's called primordial testing. Lower is better, longer is better, earlier is better. That's the mantra with ApoB.
I think it's great. But I have a couple follow-up questions. I want to touch on LP little a in a second, because you mentioned it, something that I is interesting to me because, I've taken LP little a tests and I have, in the not astronomically elevated, but I've seen it. I've seen the genes for it. But with kids, just to start, kind of circle off this kids conversation. What do you do? I mean, I think there's going to be a lot of people that are going to nod their head and say, yes, you got to get tested. But I also think that there's going to be a large number of people who are going to be very squeamish about having their kids on, a pharmaceutical intervention when they're young.
It depends how high their levels are.
Right, of course.
A little bit up, you're not going to go to pharmacologic, but there are thresholds where it's genetic. And therefore, you either deal with the long-term consequences. And obviously, with children, you have a long time before the endpoint is going to occur. But there are certain thresholds where it would be malpractice not to start pharmacological therapy.
No, absolutely. I mean, but you have these competing voices out there that I think people are influenced by, and they're going to want to hear your perspective on. On the one hand, you have, I'm sure you've heard of David Sinclair at Harvard. He's a longevity scientist, runs a genetic lab, and he talks about his routine. He's having yogurt every day for breakfast, high-fat yogurt as a low glycemic intervention. But he also is on a statin. He's been public about that because he wants to keep his ApoB low. He sees the science of that world and recognizes that's an important risk reduction factor. But then there's also people online, this is going to go on YouTube, people who are adamant that the way to solve for this is just go on a vegan diet, whole foods, plant-based diet. That's what everybody should get. What's your opinion on, vegan, plant-based, Caldwell-Esselstyn interventions, that whole community? They're very adamant that is this.
Now, listen, after you get your metabolic markers evaluated by somebody who knows how to interpret them, and that person works with a nutrition who's cognizant, I think different people require different types of diets to perhaps try and control whatever metabolic disarray they have. And that wouldn't be me. That would be a competent nutrition saying, yeah, you should be on a vegan diet, or Mediterranean diet would be fine with you. And then they would do that. And then whatever reasonable diet you choose, you're going to follow these biomarkers and see, have you helped them a little bit? Have you done nothing? Have they got worse? If you really do most of these reasonable diets, they're not going to get worse. But at a certain point, if you try whatever lifestyle, that means nutrition and, exercise and other, don't smoke, all the other things that go along with it, and your ApoB still exceeds a certain threshold, then your choice is pharmacological therapy. Then you have to sit down with somebody who has mastered pharmacological therapy and the many agents that are available to us nowadays, and can have a discussion with you about the pluses and minuses of any of the therapies. As you know, there's no perfect drug in the world that works exactly as it should, or there might not be a little downside to it. With the lipid modulating drugs, we know what those downsides are. So you can have a nice discussion with a parent if it's a kid who needs it, or a teenager, or once they're 21, you have the discussion with them. And then it's a free world. They could go out, and if they've spoken to a credentialed expert in this field, and they want to go on the internet and follow Dr. Google, hey, it's a free country. I'm around to treat them when they come back with their coronary artery disease or survive their first atherosclerotic event, if they survive it and are not handicapped by it. So look, it's always a patient's choice. And there is so much crap on the internet nowadays. Look, I just crossed 29,000 followers on Twitter. And as you know, my tweet posting are 100% lipids. I'm not discussing other things on Twitter. So I have a massive amount of followers. David Sinclair is one of them because he comments every once in a while. I'm always thrilled to see top-level experts chime in once in a while. But I get a lot of nonsense to me. And look, you're allowed to spout nonsense to me once, and then I give you references or here, but you better read this. And if you're going to continue to spout nonsense, then you're just muted. I have no need to hear from you again. Twitter gives you an opportunity to correspond with what most people would recognize as a mega lipidology thought leader. I don't want to brag, but in fact, in a few days, I'm flying to Atlanta. The National Lipid Association is having its annual meetings this weekend in Atlanta. Mm-hmm. And the reason I'm going, because I don't fly anymore. I don't like to fly. My heyday, I did 3 million frequent flyer miles, but no more. But I'm going because I am being presented with the National Lipid Association Foundation's award for being the 2023 Clinician Educator. So if you correspond with me on Twitter and I answer a lot of people if they have reasonable things, you're getting knowledge from somebody who at least the real lipidology world recognizes as an expert. And if you want to ignore me and go jump on some nitwit's blog or advice, hey, I'm not even charging you on Twitter. In my heyday, you would have had to pay serious dollars to come and get my advice. But for Twitter, it's free. But it's amazing how some minds cannot be changed. The last thing I'll tell you, I've been 35 going on 40 years in lipids. I've read practically everything. I've traveled all over the world, meeting thought leaders, teaching, absorbing things those folks teach me. So zero of these nonsense people who are tweeting or putting on, so they have not even a background. It's 1/10 of mine. So
yes, and congratulations on the award. I had that in my notes. We were going to get to that at the end of the show and make sure that people knew about that. Of course, we're not breaking news here on our show. People know about that on Twitter, and that's a huge honor. And congratulations for receiving that award.
Yeah, especially at my age, I'm an old dinosaur, and they still see a need to give me an award. And I think a large part of it is because of my massive Twitter feeds on lipidology. And also I do podcasts with reasonable people like yourself to spread the word too. And I've done so much of that. I've become way more well-known than when I was traveling the globe doing 400 lectures a year. Yeah, on one day in Twitter, I could reach more people.
Well, I mean, the series that you did with Peter Attia, the essentially the several part it was probably 5 years ago now. The several part cholesterol.
2018,
That
right?
was that was an excellent. And there's a lot of people out there who are really looking in earnest for to figure out. This is such a tribal issue. It's become such a tribal issue. It's a very confusing space to navigate. And there's people out there that are looking for information, and you're definitely one of the trusted, most trusted voices. So we're always. I mean, I'm thrilled to be able to pick your brain and talk to you. And yeah, I think that's why people enjoy your content, because they know it's backed by quite a bit of expertise.
Yeah, and most people would respect that and listen to it. It's funny. I got an email this morning from a woman who's somewhere in the United States and said, and it was a very eloquently intelligent written email, and said, I my doctor ordered an LP little A test, and it was in the stratosphere. And my doctor didn't know what to do about it. My doctor told me, don't worry about it. Uh, so, but she did her own homework. She started examining, searching LP little a all over the place at legitimate places. And somehow my name popped up a lot, which it should. LP little a has been a big part of my life. I've published on it, worked in labs for 7 years that were doing serious testing and research on it. But the email was so nice, and I have no idea what to do with this. And she left a phone number there. I actually called her up and spent a half hour, 40 minutes with the woman, got into a nice discussion, and of course, punted her to the people in her locale that could handle her and give her good advice. But it's baffling to me. Her doctor, I said, why did you get an LP? She's in her 50s, early 50s. Why did you get an LP little a test? She goes, oh, I don't know. My doctor ordered it. And I said, well, did the doctor? And then the doctor comes back and tells you, don't worry about it, when it comes back deep red on the lab report form.
Wait, but what do you
It's so
do?
bizarre.
What do you do? Because I see the conversations you and like Sam Tamikas have on Twitter, and we have in our polygenic panels that we run. There's you can see the LPA genes. But the thing is, like, I know there's pharmaceutical interventions that are coming along that are maybe yet to be approved or are promising. But it's like you say test once. I would say to you is like, okay, you have sky high LP little a. What are you supposed to do about that? Is there a drug you can take now?
Yeah, no, there's a standard of care in what you do now. As you sort of indicated, there is no FDA approved drug on the market that is approved to reduce LP little a. But in fact, there is one drug on the market that can drop LP little a by around 25-30%, and they would be your PCSK9 inhibitors, which are on the market because they drastically lower your LDLs that don't have apo little a attached to them, which statins and ezetimibe and bempedoic acid can all do. But none of those therapies lower LP little a, but PCSK9 inhibitors do. Now, there's a lot of research being done on 3 or 4 compounds that actually stop the liver from making apoprotein little a. So if you don't make apo little a, you can't have LP little a particles. The closest one is probably 3 years, 2 to 3 years away from completion of its trial. If that trial is successful and the drug shows no safety issues, then it might come on the market and be approved. But the trial is only being done in nightmares who have very high LP little a and have already had a heart attack or stroke. So the odds are good that the FDA would say, oh, we'll approve this drug for those nightmares, but we're not going to approve this drug for primary prevention, the people who have high LP little a who have not yet had an event. So we'll see how that all pans out. There are other drugs that are going to take more years coming down the pike. So one day I think we'll have this solved. But until then, if I had a PCSK9 that was in the higher range, a lot of people just have less high range, moderate to a little bit of elevations. I think all you have to do in them is lower their LDL particle count, their ApoB. You're clearing the LDLs that don't have apo little a attached. And there's certainly enough data that shows if you give statins to people who have high LP little a, you do improve their risk. It doesn't go down to zero. There's still residual risk, but statin therapy and other LDL ApoB lowering therapy is the standard of care now for people with high ApoB. For the nightmares of the world, personally, I would put myself off label on a PCSK9 inhibitor. And the problem with that is if You go off label, your third party payer won't pay for it. And that's pretty much a $6,000 a year drug right now. But I often tell people with this really, really high LP little a, $6,000 a year sounds terrible, but most people spend $6,000 a year on garbage and nitwit stuff they don't need. So
Sure.
give up some of that and buy your PCSK9 inhibitor. You got to find a doctor who's willing to prescribe it and understands about it, and that's easier said than done.
So what's the latest consensus on what constitutes a danger zone for LP little I? I mean, I remember it was like, I think some of the European standards were like 50 milligrams per deciliter or higher. I mean,
if you're doing it milligrams per deciliter, it would be 75. You'd be considered high risk. With nanomoles per liter, it would be 125 nanomoles per liter. So if your LP little a exceeds that, I think you have to consult a lipidologist. The overwhelming, and this is a tragedy because this is the most common inherited lipid disorder that causes atherosclerosis. It's present in 1 out of 5 people. In African Americans, it's probably 1 out of 3 African Americans. It's horrible. So if you implore your doctor to test it, and you should, and you're like the woman who called me this morning, you find it high, and that doctor says, don't worry about it. You got to go do research and happen to find somebody who does know about it. And I would direct them to the Family Heart Organization. Just Google it. They have a phenomenal website. And part of their mission is to help people with LP little a find clinicians who know what they're doing. Yeah. Never listen to any physician who tells you you can ignore ApoB or LP little a. That is malpractice for a physician to ever say that. Never, ever listen to a physician tell you you're protected because your HDL cholesterol is high. That's absurdity in the year 2023. So, but listen, and I think this is true with so many diseases. If you don't have a run-of-the-mill disease that everybody knows how to do, you have to do your own research and find. You have to be your own advocate and wind up getting competent care.
Yeah. I think that's a good message. I mean, the thing that's interesting from our perspective too, just at Gene Food, is 3 of the issues we touched on today: ABCG5, ABCG8, hyperabsorber, Niemann pick C1 like protein, FH, familial hypercholesterolemia, and now this LP little a issue. Those are all genetically driven issues, right? I mean, it's something.
Yeah, and they're all really common. So it's not like, I'm going to test the gene because 1 in a zillion people get it. Yeah. No, this is the number 1 cause of morbidity and mortality in the globe. So good God, information is good. The type of testing you're talking about, the type of testing I do wherever I've been involved. But more important is whoever orders these tests has to know how to interpret them and know, that's good, or this is going to cause some sort of therapeutic action.
Yeah.
And it's just not known. You mentioned sterols. You can go to the NLA and take their courses. You almost never get taught anything about sterols. I've written 2 book chapters in the number 1 textbook that clinicians should have to learn about treating lipids. It's called Therapeutic Lipidology. The first issue was, 5-6 years ago. Issue 2 or series 2, edit 2 just came out last year. And in both of those, I've written the chapters on understanding sterols, but even among lipidologists, it's probably a minority who ever sat down and read that chapter.
Yeah, it doesn't seem to be on anybody's radar.
And it's too bad. But listen, there's a billion diseases you could talk about, and I wouldn't know nothing about them. And so, but I'm not dumb enough if a person comes in with a lab test and I have no clue what it is, it's out of whack, I would find out the type of person who could handle that. That's a good internist or a good physician and know when to punt, get help.
That's right. So Dr. Dayspring, you've been very generous with your time. What, if you want to just have a closing message, people out there, these interviews are designed for people that are, on the fence or confused or convincible. So what's your final message?
Listen, my answer is everybody. The odds are damn good you're going to have atherosclerosis, whatever, on line 1 or line 2 of your death certificate. It's absurd that diagnosis still exists in the world today because it's 99% preventable in most people. There's a few rare issues where, some really crazy genetic thing is at play. But in atherosclerosis is preventable. And the only way to prevent it is to test for it. And you don't wait till you're 50 years old. You don't wait till you're 20 years old. You get it in the early pediatric age group or adolescence. And then if abnormalities are discovered, and most people, they won't be discovered, but you'll be shocked how many will you do primordial prevention. ApoB is the test everybody needs beyond the lipid profile. It's done in every laboratory in America. The cash price is $20. So it's not like, oh my God, there's a $500 blood test. So that's my mission. I'm out there teaching a totally preventable disease that happens to be number one. Peter talks about the four horsemen: cancer, metabolic disease, brain health. But number one is atherosclerosis, and it's totally preventable.
Great message. It's an uplifting way to end the podcast. Congrats on your award. Enjoy your trip to Atlanta, and we will look forward to seeing you on future episodes. Thanks, Dr. Dayspring.
Yeah, anytime, John.